Welcome back. It's been a little bit. I've been sitting behind the computer for the past month designing and making preparations for the new project, the DIY fiber laser tube cutting machine. So yeah, let's get started. Okay, here's what I have so far for my tube cutting machine design. I've tried to make it as small and compact as possible because I am running out of space in my workshop. I'm not sure how I'm actually going to rearrange everything to make this fit. Since I don't use my machines for production but just for prototyping stuff, I order materials in small quantities, and what I found in my research is that I could order up to 6-foot length tube and have it shipped for a reasonable price. If I go anything longer than that, then the shipping cost just skyrockets. So I've designed the machine to accommodate a 6-foot length of tube, square, round, and rectangle. Probably the actual length of tube that I can cut will probably be closer to 5.5 to 5 feet, somewhere in that area. We'll see. Although I did design it to be scalable and accommodate longer tube if I ever happen to move to a larger shop, just by extending the aluminum extrusion, the linear guides, and the gear rack. And I also got extra long cables for the back motors. Anyways, the design is about probably 97% done. There's a few small little things that I want to figure out, while this is all coming together and make fine adjustments. For example, one thing I know I want to add is some vertical extrusion here. That way I can use the side space for material storage. But I want to start with the most complicated part of the project first, and that is the front chuck. The machine uses a 2-chuck design, but rear chuck pushes the material forward. Both the rear and the front chuck spin the material around while it's cutting. Skyfire initially offered to sponsor the chucks for this project. They have several different models available, from very high-end pneumatic self-centering chucks, and they even jointly designed a more economical front chuck to be more budget-friendly for smaller workshops. Even though they have all these great options, I found that they were just all a little too heavy for my use case. I'm trying to build a much smaller machine for cutting short spans of tube, so all of these options would be way overkill for my needs. So I decided to build my own. Okay, so here's my front chuck prototype design. And it's all based around this, I think they call it a hollow rotating platform that I found on AliExpress. It's got a 100mm bore in the center here to accommodate the material. I did some measuring and figured out that it could accommodate 3.5-inch round tube, 2.5 by 2.5 square tube, and 3-inch by 2-inch rectangle tube. And basically the design has 2 self-centering mechanisms to control the rollers. Let me remove this front plate. You can see I want to give credit where it's due. I based my design off this rack and pinion self-centering mechanism demonstrated by Thang010146. I'll link to his YouTube channel in the description. Check him out if you ever need inspiration. He's demonstrated an incredibly vast amount of mechanical systems. I could spend days watching his videos and admiring his work. So both the inner and the outer sections are pretty much the same, with the exception of some different screw holes for mounting. If I hide this one, you can see here. Yeah, so there's the back plate. But yeah, anyways, they should be self-centering, and we'll adjust the width with this screw here. To put it into perspective, the combined weight of even the smallest of the commercial chuck systems is around 275 pounds. And by contrast, my chuck design is much smaller and has a total weight of about 45 pounds. So hopefully it'll be more appropriate for the size of machine I'm trying to build. So yeah, there's a lot of parts to machine. So let's get to making them so we can get this thing built and see how it works. Let's start with the largest parts and cut this base plate first. Alright, let's try this. Everything's loaded. Everything's zeroed. Alright, that looks like it turned out pretty well. Let's get this piece off here so we can take it off the pen. Now let's cut out the base plate for the second layer. Okay, my second base plate is done. Looks pretty good. We have one tool holder casualty. I didn't measure the length of my biggest drill bit, and it ripped it off after it picked up the tool. But that's an easy fix. I can just re-3D print that. I really hate using this machine. I've been vacuuming the whole time, and still there's just metal chips just freaking everywhere. Next, I need to cut out 2 of these plates that'll hold one side of the rollers. All right, I have 2 more pieces done. And a third mistake here where I didn't leave enough material to finish the part. Then I cut out the roller plates for the other side. Okay, these 2 pieces are done. Just need to flip them over and do the backside operations. While I was waiting for these parts to be cut out on the CNC router, I used the time to disassemble my first laser cutting machine so I could reuse the parts on this new machine. Here's my version 1 laser cutting machine. It took, 3 months to build it and about 2 days to take it apart. After cutting out all the large parts, I moved over to using my Benchman MX to cut out everything else. It has the nice enclosure so I don't have to clean up all the chips. Next, I cut out all of these arms to hold the rollers. Those parts look like they turned out okay. Just need to get them out of here so I can do the second operation. Then I cut out 2 of these mounts to hold the lead screw. And finally, I cut out these 2 lead screw nuts. Okay, I've got all my parts machined finally. So now we get to have fun with the tapping arm. Quite a few holes to tap here. I've got this module 1 gear rack that I need to cut in half, and I'm going to square up the ends so they're all at the same starting point. I used a couple small little nails that fit in between the teeth to align them all up and tape them together so that whenever I clean up the edges, they'll all, have the same starting point on both the sides. Alright, so let me get this cut to length. Okay, we're getting close. I've got all the gear rack all drilled and cut to length. So now I think I just need to cut out some roller wheels and some spacers out of aluminum tube. Okay, I think I finally got everything prepared so we can start assembling this. I've got my 2 machine plates, my gear rack and spur gears, more machine parts. I've got a bunch of spacers, my roller bearings and bearings to go inside them, linear guides, and a bunch of different hardware that we need, some shoulder bolts, and some other random stuff. And it's all going to be built upon this. Let me see if I can show you here. I found it called a hollow rotating platform, and it's pretty heavy duty. It fits a 750 watt servo, so I have that on the way. But yeah, it has a 100 millimeter pass through here, so we can fit tube down the middle. So let's start putting this together. First, I think I need to add this photoelectric sensor for homing. It's got a little bracket here. Leave it attaches up here. And then it's got this little arm piece. I think it attaches right here to the side. I got the sensor installed and the little arm to trigger it over here. So let's go ahead and get this first plate installed. All right, so I think I want this to go just like that. Some M6 screws here. I think next let's install the linear slides. Just going to loosely put these in here for now. We'll have to make sure they're parallel here in a little bit. Okay, I think I'm going to go ahead and add the rails on here too. Both of these plates are almost identical, just these plates have some different holes for mounting to the platform or with some standoffs to this plate. So let's just go ahead and build them at the same time. Okay, let's add these blocks that are going to hold the lead screw. All right, cool. Let's do this one. Okay, I think these two are done for now. I think we need to work on putting all these slides together with the rollers. All right, so I have a pack of bearings here. My rollers. Not sure how easy these are going to press in here. Oh, pretty easy. Good. All right, let's start adding all these arms to hold the rollers. Grab one of these rollers. All right, something like that. Looks pretty good. All right, let's do the others. All right, cool. Two done. All right, cool. One more. All right, cool. All four are ready. Let's get these two lead screw nuts attached. It's gonna go right there. All right, next I think we need to install this gear rack. We'll start with this one. All right, one's done. All right, let's try that. Okay, those are all ready. I've got these M6 screws that I'm going to use as the lead screw. It's going to go through here. I've got some thrust bearings. I'm going to add between it. Set that on there. Should go in. One to the other side. Alright, and then I have a nut here to hold it in place. Like that. I'll snug it up a little bit. Something like that. Alright, I've got these two 3D printed parts. They're just to right underneath the gear rack and make sure it stays in position. Okay, I think it's time to add our rollers. I'm not sure what the best order of operations is going to be, so let me just kind of figure this out here. It's going to ride on here. This side is going to ride on here. Yeah, so those will move in and out and hopefully self-center if I've ever done everything right. So I think I need to get these attached to the sliders, and then we'll use that as a guide to make sure the linear guides are parallel. Okay, I just realized I can't really build this upper plate until I finish the first one, because the bolts that attach the two together go right underneath this pad right here, and so I'll never be able to access it if I build everything. So I'm going to continue with only this one, and I'm going to finish it out. Then we'll start by attaching that plate and building the top one. I've got this little spur gear on a shoulder bolt, and I need to drop it right in between the two gears here. I'm going to try to make sure they're centered before it locks into the teeth. But right there looks good. Oh look, and it dropped right in. Cool. Let me see if I can tighten that down. Alright, that side's in. Alright, it's in. Okay, that should be good. Let's test it out. Looks like it's going to work. I need to take off these 4 stops now that everything's secure and add a couple more screws in there. Okay, since this first layer seems to be all done and working well, let's start adding on the second layer. Alright, let me grab 5 of these spacers. So they're gonna be like so. This plate's going to drop on. Something like that. Alright, that looks pretty good. Now we can add these pads back on here. Alright, let's see if we can get these rollers back on here. This one's got to be threaded on here to get into the position. Okay, let's see if we can add these spur gears. Alright, I feel like that looks pretty centered right there. So we'll drop in. It does, good. Alright, cool. Nice. Alright, that feels really good. Okay, let me remove these four. Get the other screws in here. I guess now I just need to, I have spacers so I can add the top cover plate, which I need to laser cut. So now we can test it. Wow, I mean, this looks like it's going to work. By far the most complicated mechanical object I've ever built. I'm surprised actually that it appears to have turned out pretty well. Alright, well let's get that top cover plate laser cut. I have my file all loaded up here for the front plate. And I did a few test cuts. I got the parameters pretty good. Not perfect, but should do just fine. So let's cut it up. Here's what it looks like. You can see there's a little notch there in the corner. I set my origin point a little too close to my test cut, so oops, I guess it's just going to be there. And on the back you can see there's a little bit of a burr. I need to dial that in better, but I don't have time to do it today, so I'm just going to hit it with the grinder real quick and knock that off. Okay, let's get this cover plate installed. It's going to go something like this. So some spacers here. I'll just get them all started. I would have liked to get a better edge finish on this, but I was almost out of nitrogen and I don't have time to go to the store and get more today, so I didn't get to test it and get the settings dialed in as much as I would have liked. So maybe we'll remake this plate at some point. Alright, well, there's what it looks like. Okay, well, I guess I need to start working on the frame so we can get this guy mounted and test it out. Okay, I've got all the aluminum extrusion and a plethora of corner brackets, so I think next time we'll get the frame built. I've been getting a lot of new Patreon subscribers, so thank you guys. Your support is awesome and it really makes these projects possible. So thank you guys.